The father of algebra is a pretty big title to give to one man. For a while, Diophantus, the subject of my last video, was the man who was credited with this title. However, historians began to realize that Europeans were trying to take all the credit for mathematical discovery, when in reality other parts of the world were having mathematical discoveries as well. Al-Khwarizmi, the man pictured here, was one of the most prominent scholars of the Islamic world. In fact, he was the first to develop a method to solving quadratic equations, which we'll see shortly. Let's take a look. Here's an example of one of Al-Khwarizmi's 6 equations. A square and 18 roots is 19 numbers. So a square we can just write as x squared. 18 roots. So remember, a root is what we call the solution to a quadratic equation. And our solution would just be x, so we can write 18x is 19 numbers. This equation we can solve using modern methods. First of all, we need to set the equation equal to 0. So we'll subtract by 19 on both sides. Now, we can check if this equation is factorable. The only factors of 19 are 1 and 19. However, we need to look for two numbers that have a difference of 18, which 1 and 19 do. So we can factor it like this. 19 times negative 1 equals negative 19, and 19 minus 1 equals positive 18. So we have a good factorization. This tells us that our solutions are x equals negative 19 and x equals 1. That's great that our equation factored, but that's not always going to be the case. In any situation with a quadratic equation, we can always use the handy quadratic formula to get a solution. We just take the coefficients out in front of the equation when it's set equal to 0. A is the coefficient in front of x squared, and if there's nothing, that just means we're multiplying by 1. B is the coefficient in front of the x, and C is the constant out front. So plugging in those values, we get negative 18 plus or minus 18 squared minus 4 times 1 times negative 19, all divided by 2. Working that out, we get negative 18 plus or minus square root of 400 over 2, which is the same thing as negative 18 plus or minus 20 over 2, or negative 9 plus or minus 10, which will get us the same answers of negative 19 and positive 1. Al-Khwarizmi was able to prove this result a little bit differently. He started off with the x squared term, he just drew a square. And we have 18 roots. So for 18 roots, he divided it this way. He did a rectangle of side length 9 on this side, where the other side length is still our root, and a rectangle over here with side length 9 and other side the root. Well, then he just completed the big square and found the area of this. Well, we know that a square in 18 roots is 19 numbers. So this square and both of these rectangles are 19. And the big square right here, well, it's a 9 by 9 square, so its area is 81. That means the area of the whole square is 100. Now, if the area of the whole square is 100, we can take the square root of that to find the side length, which would be 10. Lastly, we know that the length here is 9, and the full length is 10, so the missing length must just be 1. So our root is 1. Remember though, last time we did this, 1 wasn't the only solution, so how come that's all we're seeing now? We also got negative 19 when we were using our modern methods. Cultures in this time period still saw negative numbers as an absurdity, and certainly in this case, it wouldn't make sense for a square to have a side length of negative 19. So therefore, when they solved these, they only ever reported the positive solutions. Al-Khwarizmi lived from 780 to 850 AD and became famous for his six kinds of questions, all equations that we could solve using modern methods of algebra. In fact, the word algebra itself comes from what Al-Khwarizmi called al-jabr, his method of adding equal quantities to both sides of equations. Well, that's it for now. I hope to see you in the next episode. Thank you so much for watching.